When you're building new products and going from zero production to more production and more production, what you actually deliver step by step may change over time. The early ones may have more expensive modules because you don't know exactly what you need quite yet, and there's no real gain for buying really low cost ones because the integration is too hard. So you might start with a more expensive BOM, bill of materials, and bring that BOM down over 2 or 3 years. However, the big mistake most people make is think, I can start with the biggest possible BOM and it will just come down naturally. It won't come down naturally. The day you manufacture your first one, you better have a really solid plan for how you're going to get to the lower BOM, exactly where the cost savings are going to come, what modules you're going to change, so that you know you're going to get there. Otherwise, you will be stuck with the high BOM. I've done both sorts, and let me tell you, knowing how to get there ahead of time is a whole lot better for your business than not knowing ahead of time.
Yeah, so my experience with production strategy is that it's especially as a technologist, it's often very tempting to do everything yourself. And that's the default, like as an engineer, I think that's going to be the default bias for a lot of us. And that, I think, is something that you have to really be really aware to make sure that you can roll out product in a fashion that is scalable.
You know, my journey up until this point has been very different, you know. At Willow Garage, it was a very kind of research journey, building research products for research customers. And then when I got to Fetch with my co-founders, we went straight from CAD to production. And that was much more based on our vast experience in building robotics products like the Freight 100 and the Fetch mobile manipulator. But now that I'm at Agility, they're in a very different journey. You know, they have up until this point built a prototype product that has been POC'd in the market, and now we're getting to the point where we're getting into a production story.
So the bill of material is really the base that tells you where you need to buy stuff, how long it's going to take to get in, how long it's going to take to assemble the robot, and basically all these parts.
At iRobot, when we decided we were going to build robot vacuum cleaners, and we were working on them 4 years ahead of when we started selling them, we were not the first to market. Electrolux had a robot vacuum cleaner in Europe that sold for 2,000 euros. That seemed awful expensive to us at the time. That was around, we shipped our first products in 2002, September 13th, 2002. So we investigated what we thought an American consumer would be able to spend without their spouse's approval on a robot vacuum cleaner. We asked a lot of people, we interviewed a lot of people. We came up with a number of $200. That was what we thought there'd be enough people who were daring enough to spend on getting a robot vacuum cleaner without having to get their spouse's approval. Because we thought a single person making the decision was more likely than 2 people debating it. So that was the initial part of the design document. There was a spreadsheet that had $200 down in the bottom right-hand corner, which was the retail price. That backed out to a COGS and that backed out to a BOM. And then the design had to fit that BOM, that bill of materials. And we had to figure out how we could get good enough cleaning performance with a BOM, which was tiny. Our budget for the onboard computer was 50 cents, for instance. Tiny, tiny amount of computation. We got that out. We sold them starting in September 2002 for $200, and it immediately killed Electrolux's idea of bringing their 2,000 euro product to the United States. And still today, iRobot is the leading producer of robot vacuum cleaners, even though it wasn't the first and it's not the biggest company that sells them, but it's still the leading producer. So that concentration on BOM, concentration on margin in those early days was critical to success.
So the beauty of having your BOM is not only you know how to build it, but you also know what is the lead time on all your components. And that has a large impact. Let's say, for instance, you can get all your parts in like, a month, but then you have a delivery delay on the motors, for instance, of 6 months. Well, then it basically screw up all your plan.
Every engineer wants to use the best possible components in the best possible way and however they think that it should be done. But the reality is that BOM is a compromise between lots of different engineers, software engineers and hardware engineers.
One of the things that you'll see in the prototyping processes is if you have multiple teams working on a piece of hardware, they might end up choosing similar components that could be unified as part of a design process, BOM scrub. Whereas if you just have independent teams picking components, they may pick very similar components, but not the same components. And then you have an extra part in your bill of materials that doesn't need to be there if a small change could be made to align those components.
And that's the place where people of good spirits start yelling at each other. No, I need this. No, you can't have that. And that's how you're going to have to live. You're going to have to really set expectations. You can't set unrealistic expectations, but it's something that has to be managed as you go from the first demos of your product to what's a real product we're really going to be able to sell that makes sense, is how to get that BOM cost down. And it requires compromises, and often it drives incredible creativity.
And often it requires somebody really capable into sourcing and handling this matrix, really complicated matrix of shipping, assembly time, getting the stuff at the right place, at the right time. It's an art, and most of the big companies today who are building goods, their magic is there. Apple is so successful because they have the best sourcing and supply chain in the world, period. That's why they're successful.
For any robotics founder out there who's thinking about getting started in robotics and you're not a strong hardware person, the one thing I can recommend to you is to find a strong hardware co-founder. Don't think that it's just something that can be glossed over and solved in software. You will gain a lot and win a lot of time back by having a strong co-founder who knows what they're doing on the hardware side, and you may be able to do what my co-founders and I did, which is go straight from CAD to production.
I think something that is really, really important, I believe, and especially if you try to do manufacturing a little bit yourself or be really involved in the manufacturing process, is that do you have a good market fit for your product? And I would ask the question again, what is your product market fit? And ask yourself the question again. And you have to really be clear from the beginning about this question, because from my experience, when you go to manufacturing, you're gonna have to make a lot of choices along the way. And again, the bias of an engineer or like a technologist would always be to like want to get everything in, but the reality is that does your customer really care? If this is not this amount, this camera, but it's a little bit less and you have a degradation of performance of, I don't know, 2 or 3%, does it really matter? Like, you have to balance it, that manufacturing is a time where you have to get back to the basics, make difficult choices based on the product market fit. Because if you don't have a product market fit, the robot will not be sold anyway, no matter how well it's built. Yeah.
This is my 6th startup, and I've also run small and very large labs in academia. In startups, when you're building product, you have a technology, you have some ideas, you think the customers will love your ideas. Usually the customers don't care anything about your ideas. They care about whether the product is useful to them. And it may not match the particular technologies that you think were the best things ever and it's really going to be cool. So once you start listening to customers, and once you start really figuring out what problem you're actually trying to solve for them, you and all the engineers you hired who came with, I'm going to work on this thing, I'm going to make this really, really good, you're going to have to disappoint yourself and a lot of other people. And you're going to have to shift and figure out how to solve the thing that's really going to be useful to the customer. Because if you don't have customers, you're not going to have a long-term business. And so just be prepared to shift, 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 shift. That's what life is like, trying to get robots out to real customers.